Welcome back. The part 1 of this video will be linked right now. Please don't hesitate to go on and check out the example that is there. Very informative. For this one, I've made it a bit more encompassing. Most of the questions you're going to find in your GCSE and IGCSE exams, of course, will come with something that looks very similar to this. So we have to sketch this graph. Note that it is a modulus function. And then we have to use the graph to find the number of solutions of this equation. So there are two parts and it's a huge question. But at the end of this video, I tell you, you're going to understand it. There will be no need for you to seek any other lesson on this one. Okay, so the first thing we want to do is to write this equation, y equals to x squared plus 8x plus 15, okay, in the form of x plus maybe h all squared plus k. You may put a out, but I'm telling you there's no need because the coefficient of x squared here is 1, which means a here will also be 1. Okay, so we will just complete the square immediately. And to do that, I will have y equals to, well, I'm going to take this out for now because I'm not needing it right now. So I have x squared plus 8x. To complete the square, I'm going to add 4 squared because I have halved 8 and I've taken the square of it. Okay. Now because 4 squared was not there before, I better take it out. So minus 16 and plus 15. Okay, so this trinomial is x plus 4 all squared. You may want to verify that, and then I have minus 1. Minimum will be at negative 4 and negative 1. So the y-intercept is 15. So that makes it easy. Now we need the roots of the equation or the x-intercepts. So if we equate y to be 0, I will have 0 equals to x plus 4 all squared minus 1. I take this to the other side, so I have x plus 4 all squared to equal to 1. I take the square root of both sides, I have x plus 4 equals to 1 or minus 1. Okay, which means x equals to negative 3 or negative 5. Negative 3, 1, 2, 3. Choosing that as my negative 3. So this will be negative 5. Now we put the minimum, which is at negative 4 and negative 1. So the minimum is just here, if you like. That's the minimum. So this is negative 1 for the y. And right here is negative 4 for the x. Okay, all moving swiftly so that I have negative 1 to be here. And that will be our minimum right there. Negative 4, negative 1. X always comes first. Okay, and then it shouldn't be too difficult now to sort out y equals to 15. So I just need 15 boxes. The next thing for us to do is to sketch this curve. So originally this is y equals to x squared plus 8x plus 15. Now, but that's not what we want, is it? Because there is the modulus symbol there. So we need to bounce this back up. That's this part that is below the x-axis. It cannot be because, you know, the values of y here are negative. And no y is negative here because of the modulus. So we have to bounce it back up so that we have something that looks like this. Okay, and what is just left is that we are now going to have to clean this part off because it should not be part of the graph. Next thing we want to do is to try and sort out the second part of this equation. So we're going to solve this where k is greater or equal to 0. Remember that k here is just a number, it's a scalar quantity. And we know that if this is the x-axis, then we know that that is also the line y equals to 0. The line y equals to 0. Okay? So this line across here will represent k equal to 0. And this is what I mean, okay? The 2 points here will be where this line and this curve meet. Okay, and because those are the 2 points where they meet, those 2 points are solutions to the equation x squared plus 8x plus 15, okay, equals to 0. Because this is k equals to 0. All right, which means that for k equals to 0, because they're only asking us to find the number of solutions. So for k equals to 0, there are 2 solutions. That's what it means. For k equals to 0, there are 2 solutions. Now, if you look at a little bit just above k equals to 0, let me draw a straight line so that you see what I'm saying. Just above k equals to 0 there, you will find out that any horizontal line will be crossing the graph at 4 points. Let me show you. Okay, if I could zoom in. Brilliant. Now, at this point here, there is a solution. If you trace it down to the x-axis, this is another point here where there is a solution. This is a point here where there is a solution. This is a point here where there is a solution. So what it means is that if I extend this line so that it becomes another k right there, I've extended it. So whatever k is here, we have 4 solutions. So for k between 0 and 1, that is between this gap here, that's between 0 and 1, okay? So for k between 0 and 1, you will notice that I've said strictly less than 1, because as soon as it gets to 1, the number of solutions reduces to 3. 1 here, 1 here, and 1 here. So for k greater than 0 but less than 1, there are 4 solutions. All right, now for k exactly equal to 1, because this is the line y equals to 1, isn't it? So for k equals to 1, there are 3 solutions. Then anything greater than that, you will have 2 solutions will be correct. So there will be 1 solution here and 1 solution here. So there will be 2 solutions. So for any k greater than 1, 2 solutions. Okay, and that concludes this example. All right.